Hey everybody, welcome to Bill Sky, the Assembly Guy, and this is a continuation video from the Getting Ready for Arrays Windows video. This is going to be how do you do the same thing that we did in Windows in Linux. And actually there's some content here that is applicable to Windows that we didn't do, but makes Linux kind of a more robust and more, I don't know, configurable operating system for assembly language development. So what we're going to do is I'm going to take the code that we did in Windows, or code that's very close to what we did in the demonstration. I'm going to copy it and paste it in my Linux application and show you the differences and show you how we modify the Linux program to work on Windows. So let's get to it. So I'm going to go ahead and create a 64-bit assembly language project. And they're beginning to build up here. And I'm going to call this one 64-bit or Linux 64-bit. Getting ready for arrays. Pretty much what we called the Windows version. And now what I'm going to do is I'm going to copy and paste the stuff that we did in Windows in Linux, and I'm going to show you the changes that have to be made. Oops, here we go. So pretty much everything is the same. I'm going to save and build this, and you're going to see right away that there is one problem, and that's this right here, the continuation of our array from 4 to 7. In Windows you can put a comma there. In Linux you can't do it. So in Linux what you do is you get rid of that comma and you put a DQ right there. And by doing that you have a valid 7 long array. That's it. That's all the difference you have to do in the data section. Now I'm going to go into the code section and I'm just going to copy all of that. And you can't see it, but you'll see it in just a moment. It's a secret. And there's all the code that we did in Windows. Now let's organize it a little bit here, get things kind of lined up, things look good. Okay, now let's just go ahead and do a build and see what we get. Well, we get a number of problems. The first problem is this one right here, offset. Offset in Windows says that I want to get the address of a byte array, and I think I have it spelled incorrectly. Oh, that's another thing too. A byte array all in capitals is the same as a byte array with a lowercase a in Windows. But in Linux they're different. So you've got to put the capitalization. It is case specific. But that wasn't really the problem. The problem here is that it doesn't know what this offset thing is. Now offset in Windows, as I was saying a moment ago, that means give me the address of a byte array and put it in RSI. But in Linux, you don't have that. You don't need it. In Windows, it's like almost like a macro that Microsoft has. So you don't have to put square brackets around your variables to dereference them. You can just use the variable name. So you must use offset. But in Linux, you don't use offset. So we're just going to go ahead and delete that offset. And now that one works. So everywhere where I see an offset, and I guess it's only one place, anywhere we see an offset, we just get rid of that, and now the code's fine. There's another problem here, is that when we move a byte array, now we're saying move ZX, RX, a byte array, we're actually moving the address of a byte array. So if we want to dereference it, we have to put square brackets around it. So that's going to dereference it. And that's going to build okay. However, it's going to move 8 bytes starting at a byte array. It's not going to actually stop at just a byte. It's going to move all 8 bytes. And if we debugged that, you would see it. In fact, well, we can't debug it because we have a bunch of problems, but we'll leave it there so we can see the debugging to see what happens. Okay, so the next one is this byte PTR. And really what we're trying to do is we're trying to move a byte that RSI is pointing to into RAX using the move 0 expand. And you don't need PTR on Linux. It's kind of built in. So now if we make it, that problem goes away. So everywhere where you see PTR, you don't need that PTR because Linux MASM automatically works with PTR. All right, great. Let me see. Okay, so the last thing we have to do is that we have to implement type, size of, and length of. There is no such thing as a type, size of, and length of operator or keyword in MASM Linux. So what we're going to do is we're going to do something. This is the new content, and we're going to create some constants inside of our data section to implement type, size of, and length of. Now remember, type on Windows means what is the size of a single individual number that is being represented in the array. In the case of a byte array, I'm going to say dot type equals 1. So for a byte array, each item is equal to 1. And we'll see examples of how to use that in just a moment. So I'm going to put that on every one of these. And for a word, it's 2. For a double word, it's 4. And for a quad word, it's 8. So let's build that. Looks good. We still have some issues down there, but we're about to fix those. So type says how big each item is. Now we can actually go in here, and instead of saying type, I'm going to say byte array dot type. Instead of type for the word array, I'm going to say word array dot type. And that's pretty much it. So let's build it. Let's see what we get. All right, so those errors are gone. Now, the assemble errors are gone, but it doesn't mean it's working the way we want it to. We're going to have to do a few other things. So size of. If you remember, size of in Windows means the total number of bytes. Now, if you have the total number of bytes and then you have the type, you divide the total number of bytes by the type and you get the length of, the number of items in the array. So let's see, how would we implement size of? So what we're going to do for size of is we're going to say dot size of, that's equal to, now we're going to say dollar. Now what dollar stands for is the current memory location. That's the memory location right after our 55. So the current memory location address minus a byte array. So a byte array is pointing to this one. That's the first one. The last one is after the 55. So if we take the address after the 55, subtract the address of the 11H, we get the total number of bytes in that array starting at byte array. So dollar is the current address in memory where this statement is located. So we're going to do that for all of these arrays. And all we have to do is just change the array name. And we're going to jump down here now. Actually, let's go ahead and build this, make sure we didn't do anything weird in the data section. Looks good. Our error list is getting smaller. So our first one in size of, just like we did with type, we're going to say a word array dot size of. Let's save and build that. Okay, great. Lastly is length of. Now length of, as I said, was size of divided by type. So we can come up here and we can say dot length of, and let's align our equals just because I'm a little obsessive compulsive. And what we're going to do is we're going to say a byte array dot size of divided by a byte array dot type. Now this is kind of nutty to do it that way because all we have to do is say something like this, a byte array dot size of, and we don't have to divide it by 1. Okay, But I do it for consistency reasons. So now look what I can do. So let me save and build that first, make sure I didn't type anything weird. Okay, now let me go ahead. Now this is why I do it that way. I just go ahead and paste it on all my other arrays and just change, and I don't have to worry about some of the lines look different than others. They all look the same. The equation is basically it. And actually, I think I didn't paste these correctly. Here we go. All right, great. Now we're going to go down here, and instead of dot length of, we're going to say a word array dot length of. Save and build that. Okay, so let me see. So now we have some other things. It says, oh, yep, I forgot the upper and lower case. So it should be uppercase here. And let me see. Oh, I've got a lowercase a. This is why I build a lot. Oops. A word array dot length of. Did I put a dot there or a comma? All right. So it kind of goes through multiple phases of the assembly, and now we got done with all the syntax. Now it's going through the actual conversion. And what it's doing right here is it's saying, how much are you going to move into RAX starting at a byte array? If I don't specify, it's going to start here, and it's going to put 8 bytes into RAX. Now this is only 5 bytes, so what's it going to do? It's going to start putting data from this variable. So because all of these are contiguous, they're right after each other, we have to specify the size. So we're just going to say byte. And then line up our comments. Okay. So that's pretty good. So let's see if I can see anything else that is... Okay, that's fine. This is move... So what we're going to do here, we're going to move 8 bytes. Oh, yeah. So this is going to dereference RSI. A byte array has that. So RAX will now contain all 8 bytes unless we specify byte and move ZX. So we're going to see that in the debugging. All right, great. So let's go ahead and debug this. And let's walk through it as we debug it. Okay, I'm going to zero out the register, so I'm going to put my breakpoint on the register 0, just like we did in Windows. And we move a 0 to RSI and a 0 to RAX. Now, if you remember, if you watch the Windows, RSI and RDI, those are registers used to contain addresses. RSI is the index register. So it's very common to put addresses in RSI. RAX is the accumulator register, kind of like the garbage register. We put all of our calculations in there. It's a standard way of doing it. So that's why we're zeroing that 2 out. We're going to use those 2. Okay, so now what we're going to do is we're going to move a byte starting at a byte array, and we're dereferencing it into RAX. Now if we go back and look at a byte array, it has a value of 11, 22, 33. So it should put a single 11 in there. Okay. Let's go ahead and do that. Step over. And now it has 11. Now what we're going to do is we're going to move the address of a byte array into RSI. Now with Windows, you'd have to use the word offset. Linux, you don't have to do that. So now we have the address of the byte array. We're going to move into RAX, the dereferenced address located in RSI, which is highlighted here in green. I'm going to step over, and look what we got. Because we did not specify a size of the number of bytes to move into RAX, it just started at the address that RSI was pointing to, which is the address of a byte array, and just started putting it in. Notice things are backwards because of a little endian order. So if we actually just want to put a single byte, we have to specify byte with the dereference of the register that contains the address, the destination, which in this case is RAX, and then move ZX. So let's step over, and there we go. So now we're back to 11. So now we're going to add into RSI the type of a byte array, which should be 1. So we can actually look at RSI right here. It's 405036. It should change to 405037, which it did, because that is a 1, because each item in the byte array is 1. And now we're going to move the second item in the byte array into RAX, which is 22. Now the reason why I put data in my arrays like this is so it's easy for me to see, oh, that worked. That put 11, then 22. If I did it again, it would put 33. Okay, great. Now what's the next one doing? We're going to move the type of a word array into RAX. Now, every word is 2 bytes. So let's see if that worked. Yep, so it moved a 2 in there. Now we're going to move the length of our double word array into RA. Actually, no, it's going to move the size of our quad word array, which are the total number of bytes in the quad word array, which is 38 hex 56 decimal. So there are 7 items in the quad word array times 8, because each item is 8 bytes long. That's 56, or hexadecimal 38. So our size of works. It shows how many bytes are in the array. Length of divides that by the type, and in this case the double word array. So if we go back and we look at our double word array has 3 items in it. So we should get a 3, which we do, into RAX. So I think that's pretty cool. So we took a Windows assembly language program, made a few changes. We actually implemented the type, size of, and length of for array processing. We could do something additional here, like let's say on our quad word array, I could move into RSI, comma, the address. Oh, we don't want to dereference it. A keyword array. So that's going to move the address. And then I can just say move into RAX, dereferenced RSI. Now the reason I don't have to put anything here like a byte or a D word or even a Q word is because RAX is a quad word, RSI is pointing to a quad word array, and you don't need that Q word there. However, you can put it there for documentation purposes. It doesn't really change anything in your code. So move a quad word into RAX. Now if we want to go to the next one, I'm going to say add RSI, comma, a Q word array dot type. Go to the next value in the array, and then we're just going to copy and paste this so we can see the next value. So let's go ahead and quickly debug that. I think you know what's going to happen. I'm showing you how to begin your array processing here. So let's stop right there on that's our new code, and let's run it. Okay, so we're going to put the address of a quad word array into RSI. You can see it right there, 4F. We're going to then dereference RSI and put that value into RAX, which will be down here. Step over. You can see it, all E's. You can always jump up and verify that's the right number. I promise you it is. Now we're going to add to RSI the quad word array type, which should be 8. And we'll see what F plus 8 is. It's 7. It's 57 instead of 4F. Now we're going to move a dereferenced RSI into RAX. And we have all Fs. And if we jump back up here and we take a look at our quad array, we had all Z's and then we had all F's in the second one. So you can do this for as long as you wish. Now the video after this, I'm going to be producing an ARM video, but actually the video after this We might be getting into arrays and actually see how to move arrays around, the data in array around. We might be doing something else. We might be messing around with the stack or procedures, but actual using the knowledge from this video is going to be very applicable in a very, very forthcoming video on arrays, because that's really what most programs do, is they deal with quantities of data, arrays of data. Even though they might be like a vector or something like that, it's still a group of data. So hope to see you at the next video.